Alright, so here we are with 5-6 assignment, and we are doing part 2 here, where we start with problem number 25. So in the previous video, we already decided that this triangle will exist, and so will this. So now we just need to use Huron's formula to solve and get the area. So taking a look at our formulas, we are going to be using this one here, where we need the semicircle length, and then we can end up finding the area. So, this one. So that means that I'm going to find S first. So I'm going to take 19.3 plus 22.5 plus 31 and divide by 2. So I get 36.4 divided by 2, and we get 18. Which means that our area is going to be the square root of 18.2, but that's going to be subtracted from every side length. Alright, and square rooted. I feel like I'm getting it in a negative, but here we go. I'm just going to re-add. Oh, well, that is different because I already divided by 2. Okay, 36.4, not divided by 2 again. Okay, so that changes every single one of these to 36.4. I just decided to divide it by 2 twice. You know, for fun. Okay, so 36.4. Alright, and so inside, we're going to get, when we type all that out, 46,720.3464. Super. I mean, we are talking about area, so it can be what it needs to be based on the lengths. So apparently the area is 216.15, and again, we don't know the units, so just units squared. Alright, and then the next one, I'm going to find the semi-perimeter again. Hopefully this time I won't divide twice. So I'll add each of the pieces together. And so we end up with an S of 33.4 plus 28.5, 22.3 divided by 2. So 42.1. Alright, and so to find our area, we're going to do the square root of 42.1 times 42.1 minus 33.4, etc., etc. Alright, I just ran out of room, so really that means the square root of 98,629.1856, or 314.05. Excellent. Alright, so moving on to our last 3 here, we want to find the radian measure of the largest angle in the triangle with sides of 4, 5, and 6. Okay. So, the largest side angle is going to be across from the largest side. So we're going to put, when it comes to the equation, we're going to maybe call this one A, and use the cosine equation, because of course we don't have any angles. So the law of cosines says a squared is equal to b squared plus c squared minus 2 times b times c, and cosine of A, and again A is going to be the largest angle if I've made the largest side A. So, how do we make it in radians? All you need to do is make sure you're in radian mode when you solve. And I called it radium. There we go, radian. Alright, so our A value is going to be 6, and then it doesn't really matter which one's B or C, but we've got C of 5, cosine of A. So to solve as we've done before, we need to evaluate each of these pieces. So 36 is going to equal 16 plus 25 minus 40 times cosine of A. And then we have to move over our values. So 36 minus 16 minus 25 leaves us with negative 5. But then divide by that negative 40. And we get 0.1, that's not a 125. And so again, to undo cosine, we do cosine inverse. Make sure again we're in radian mode. Second cosine of the decimal means that angle A is 1.45 radians. Alright. Okay, so then number 31, they want you to find the area of a regular hexagon inscribed in a circle of radius 12 inches. Alright, so there's a lot going on here. We've got a hexagon, so that's 6 sides, inscribed in a circle. And so that means that whatever we get, we're going to multiply by 6 because there are 6 triangles that would be within it. Within that circle, the central angle is going to be 360 divided by 6. And so that's 60 degrees, so each of those is 60. And then, of course, they told us that the side length was 12. And so this opposite side would have been the other angle. But turns out we don't need it because in our formula for the area of a triangle, we could potentially use sine of one angle and then the 2 measurements of the other. So the formula says half of the 2 radius in this case times the sine of the central angle, which would be A in this case. So again, B is 12, C is 12, and angle A is 60. So filling that in, we have a half times 12 times 12 times sine of 60. And then whatever we get, we're going to multiply by 6 in order to get the hexagon area. Alright, so let's see, what's a half times 12 times sine, going back to degree mode, of 60. That's 62.3538. Again, times 6 means that the area is 374.12 units squared. Alright, and then the last one, we want to find the area of a regular hexagon circumscribed around a circle of radius 12. Okay, so we've got a circle and a hexagon around it. There. And so the regular hexagon, so that means that this piece is 12 inches, which is the height of the triangle versus the radius, or the isosceles leg side. So we now know that this is 12 versus all the rest of them. All right. We also know that since it's a hexagon, again, the central angle of each of these is going to be 60. And so this angle is 60. And since this is an isosceles triangle, that means that this is an angle bisector. So technically I have a right triangle, getting mini here, with an angle of 30 degrees and a height of 12 units. And I would like to know this side length. So, in order to get that side length, use a little bit of trig. I have the adjacent side, and I want the hypotenuse. So adjacent and hypotenuse is cosine. So to solve this, we get cosine of 30 is equal to adjacent over hypotenuse, so 12 over x. If we make that into a proportion, that means we do 12 times 1 divided by cosine of 30 in degree mode. And so our side length here becomes 13.86. And so now that we know that that's 13.86 inches, again, that is this length as well. And so now we know in our formula, as we did before, that our b value is going to be that number we just got, 13.86. So is our c value, but our angle A is going to be 60 as it was before. So we'll do a half times 13.86 times 13.86 times sine of 60. But then remember that we're going to multiply whatever our answer is by 6 in order to get the hexagon area. And so, let's see, times 13.86. And then sine of 60, so we get 83.1816, and times 6, which is 499.09 units squared. Wow, that was kind of a long assignment. Hey, but now I feel like we all know a little bit more. Alright, so that was part 2 of the 5-6 assignment.